Hello, today we will be solving section 2.8, problem 35. The question reads, if two resistors with resistance R1 and R2 are connected in parallel, shown in the figure here, then the total resistance R measured by ohms is given by 1 over the total resistance equals 1 over R1 and plus 1 over R2. If R1 and R2 are increasing at rates of 0.3 and 0.2, how fast is R changing when R1 is equal to 80 ohms and R2 is equal to 100 ohms? So first thing we need to do is we need to figure out what what the total resistance is at this point. So we have these two values, so we can just plug it in straight there without it doing any calculus. So let's go ahead and do that. Start out doing 1 over total resistance, which is equal to 1 over 80 plus 1 over 100. This simplifies to 18 over 800 equals 1 over the total resistance. So then we could just flip these over and we will get the total resistance is equal to 800 over 18, or 44.4. So let's write this over here quickly. 44.4. And then erase this to give us some more space. Now that we know the value of the resistance at this point, we can now try to solve for the rate. So we have this, our equation again. All that we're going to do is we're going to start out by doing the quotient rule on each one of these individually to give us our derivatives and our rates in the equation. So starting out with total, we will go 0, because the derivative of 1 is 0, times total resistance minus the minus 1 plus dRT dt. Let's put the little bracket on there. And this is all over total resistance squared. So this is what the whole quotient rule will look like. For simplicity's sake, we know that we're going to be doing the same thing on each one of these. The only difference is, instead of the total resistance, it is going to be R1, of course, substituted in, or R2 for the other resistor. And first things we see is that this all equals 0, and then we don't need the negative 1 there, so this can simplify down to negative dRT over dt, sorry, negative RT with respect to t over the total resistance squared. And then we could put that in for the others also, which would be the negative that with respect to time over R1 squared plus negative R2 with respect to time over resistor 2 squared. Okay? So all we did there was just quotient rule on each one of these. Next step would be, because we know all these values, just straight plugging it in. So to do that, we just go our total with respect to time over 44.4, which will be squared, is equal to negative R1 here, which is 0.3, over 80, which is also squared, plus negative 0.2 over 100, which is squared. So we can take this down and simplify it even more. We're going to need our calculator for this one. So negative 0.3 divided by 6400, which is 80 squared, of course, gives us negative 4.6875 times 10 to the negative 5 plus, actually, leave that off. We know it's going to be a minus because we have this negative up here. Minus negative 2 times divided by 10,000. Negative 0.2 divided by 10,000. Which is equal to negative 2 times 10 to the negative 5. So now we can add these together. It's going to be the same as there. And we get 6875 e to the negative 5 okay, negative 6.6875 times 10 to the negative 5. And then we could multiply this whole thing by 44.4 squared. Sorry, probably can't read the handwriting over there. So with that, we will get negative 6.68875 times 10 to the negative 5 times 0.4 squared. Oops. There it is. With that, we will get negative dRt with respect to time is equal to negative 0.138318. And then we just take those negatives off, and we get our final answer, which I will write up on the top for everyone. Over dt is equal to 0.132. There you go. Thank you for watching. Have a good day.